Welcome, great learner, great structural engineers. And in our previous video for this school project, we load it, but now we are going to be doing the analysis and design. Before we proceed to the analysis and design, first thing first, we have to set our parameters. When I say set parameters, what do I mean? You come to this analysis, select building. Then from this building, you have to wait. Let's wait a little bit. So from here you have to set your parameters. You see setting center. First of all, you come here, edit your materials. So when you click on edit your material, here we said double click here to choose our concrete grade, because it is what you put to the software that now we are going to use either 20 Newton per millimeter square or 25 Newton per millimeter square. You can choose any grade you want. Now we apply to all the member. Now we click OK. Here we're going to select our reinforcement grade. Oh, click here. Well, let's use 460. 460. Let's edit the diameter of the reinforcement by clicking this edit. Now this is column, so we are going to say we are going to choose between 12 mm and 16 mm. So between the range of 12 mm and 16 mm, off everything. This software will pick between this region, the one that's suitable. Wall we are not designing, we will ignore that. Come to this beam. This beam we are going to be choosing 12 mm and 16 mm as well. So we are going to turn off the remaining one. Now we'll come to our slab. This is our slab. Our slab we are going to be using 10 mm and 8 mm for where it's suitable. Then we'll off the rest. Because if you do not turn off the remaining one, the software can choose 25 mm for slab. So that is why we choose the preferable and available rebar size. This is the footing. For footings, we are going to be using 12 and 16. 16. You cannot come and choose 14 because it's not available. Although the software into pass design, but you cannot see it in the market. So we have 12 and 16 for the footing. So we have to turn off the remaining one. Now this is where people made mistake. This is the link, the steel ropes. So steel rope we are going to be using 8 and 10. You cannot choose now because now it's not available in the market. So after this, we now say OK. After clicking OK, we say apply. Apply to all members of the material classes. This is story. Click OK. Now click OK again. After that, we have to go to the setting center. Here, that's where we get mistake when you want to do analysis. When you are doing your design, your detailing, that is where you do the settings. Now, first thing, you click on this setting centers. From these setting centers, you can choose the depth, the foundation size range, and what software to work within, the thickness range. Now it has opened now. First of all, let's start from the bottom. Come to our foundation general. Now you can see this general. From here you can change the allowable bearing strength of your soil. He has given us 200 kN per meter square. The soil unit weight is 18 kN per meter cube. Now concrete, link concrete cover. This is the blinding 100 mm. Let's change it to 75. Now strip footing cantilever, so we leave it as it is now. Now we'll come to this side. Minimum footing size. Let's say we use 1,200. Minimum footing size, that is the size of the footing. 1.2 by 1.2. Minimum thickness, let's take 250. Now, if this 250 and this 1,200 is not passing, the software will tell you, you will know how to adjust. That is why you have to have the basic knowledge and what is obtainable. Now, you come here, see, use top bar. Those one are thick. If you untick them, that means your footing is going to be singly reinforced. So, we want to do a singly reinforced footing, you have to turn them off. And here we're having minimum bar 16 mm. 16 mm. Let's leave it. Let's say we leave it as it is now. Now we're not designing piles, so we just leave it like that. We'll come to our slab design. Our slab, those are the design conditions. So if you understand basic structural design, you will understand what we have here. The percentage. Now we'll come to our rebar. For our rebar, we are going to be using minimum bar as 8, minimum spacing as 10. Maximum spacing as 100, maximum spacing as 200. Then here, make bottom bar, so you see with your condition. Now, if you are cutting the reinforcement, the minimum size, maximum available size of reinforcement is 12 meter. 12 meter. So that's how it is like that. So the cutting length of the reinforcement that the software will take now is going to be 12 meter. Now, we come to our appearance. If you want to make any changes, change anything here. Now, show number of bars in bar label. That means when you do your detailing, you We want the projection to indicate the number of bar on a particular line. Now we are done with this lab. We cannot come to this beam where we would have to do a lot of job. Please come to our design conditions. Now come to our parameters. Now come to our parameters. Minimum bar 12, maximum bar 16, which is what we selected earlier. One over Hagar bar 12, one over Hagar diameter is 12. So you know what those things mean. Now here we are considering the floor beam, not rib, no foundation. We don't have foundation beam. All the beam are floor beams. So that's why we consider only this part of floor beam. So you can see the maximum spacing of steel ropes now is 300, which we are going to take 200. Minimum space is 100. And maximum spacing again here, we are going to take 200. Then we leave this spacing as a steeper increment. Like this one with 25, if you want to increase on software, here you have 200, now it will now increase to 225, it will increase to 250. That's why we leave 25 as increment, length of increment. So now web is 16 mm. If I told you it's a web reinforcement, we take this. Now these parameters are set. Now come to this rebars. So rebar patterns, from here you choose your design pattern, the way you want your detailing to look. So many designers made mistake by not checking here. From here you have issue. Now as we come here, if you click on this first pattern, something will display here. Here you see the default pattern. Just wait a little bit, you see the pattern in which your reinforcement is going to be detailed. But if you took the first one or the second one, it will determine how our reinforcement is going to look when we are doing our design. So you see, this is the pattern. This is this first pattern. You see the way the detail look. Let's say we click the second one. You see the way the detail look. So you just be observing. We click this one again. You see the detail it changes. So if you come to this one, the detail will still change. So it depends on the one you choose. So mind you, what you design, you have to give a design that is probably understandable by those who are going to be working on site. So if this is how it's supposed to look, if that is how you want it, you leave it like that. So that is just it. You see, this one is okay. You can see the arrangement here. So we are going to take this first one. So here we can come to steel selection method. Now we check bed up. So the way you want it to look like, you just have to adjust it. Now come to our legs, our steel ropes. So this is it. The kind of steel rope you want. This is closed steel rope. If you want open one, you open. If you want standard, you choose standard. So we are going to be using standard. So if you fail to make changes here, it will appear on your design. So we come to containment. So you can see your steel bar, your containment. So we want to go to detailing now. So we go to beam. From here we change section. Now you see section now. We don't want everywhere to be section. We just say section only span. You see it now. If you do not tick that, the whole beam will be section. Now here people made mistake. You see this instructive. Now you see, if you did after drawing, this is how it's going to look. So we don't want this A to here. We want it to be fully detailed. So we have to toggle this off. You see the way it looks now. That's how this sidebar and all that. So column does not have too much problem because you will still going to do modification after design. So we leave it like this. We say okay. So that okay. Now we have set all the necessary settings. Now we now proceed to the analysis. For this analysis, before analyzing, let's check our model if it is okay. First of all, click on this check. You start your model check. Now it is going to run the check and show you the number of error you have. Then you have to go and face the error if there is any before you proceed to the analysis. Otherwise, your analysis is not going to be perfect. Now you can look here very well. The building model check completed. Number of error is 0, so we can close it. Now we proceed to building analysis. So when we building analysis, we wait for it to pop up. Now here we are considering column reinforcement. We tick it. Beam reinforcement. We tick it. Now we are analyzing and design. Sometimes you can decide to analyze without designing. If you want to analyze without design, you can just tangle this one up to analyze the building. You understand? But now we want to analyze and design. We click this one. Okay, let's analyze and leave design. We click analysis. Now from here, it is going to analyze the whole building, but it's not going to design any element. How are we going to know that? After analysis, we are going to use the review to check if any member has been designed. After, if any member is not designed, we will now run our design. From our design, we still go to our review again, which is here. From our review, we now check the number of members that are passing the design and the number of members that are failing the design. Then from there, we can now proceed to design the field